Oxygen is essential for life. The constant flow of oxygen to all the body's tissues is necessary to sustain life. Oxygen deprivation, called hypoxia, is a key factor leading to organ failure in many life-threatening conditions, including stroke, heart attack, the treatment of cancer, and respiratory diseases, such as COVID-19. Trans-sodium crocetinate, or TSC, is a first-in-class small molecule therapeutic designed to combat hypoxia. It is a long, rigid molecule designed to enhance oxygen diffusion through blood and tissue, through the lungs, onto red blood cells, and ultimately to the organs and tissues that are using oxygen for fuel. To show this, let's take a closer look at the process of oxygen diffusion. A concentration gradient exists between oxygen-rich blood and the oxygen-consuming tissues, especially during periods of hypoxia. To equalize the concentration difference, oxygen moves from the area of high concentration in the blood to the area of low concentration in the tissues by a process called diffusion. For an oxygen molecule to enter either a circulating red blood cell or a target tissue, it must pass through an area immediately adjacent to the red blood cell or tissue, where the flow of blood is different from the center of the vessel. This area is called the transition layer, and research studies indicate it is the highest source of resistance to oxygen diffusion. The transition layer, like plasma itself, is 90% water. Water molecules are loosely bound together by a chemical attractive force known as hydrogen bonding. These hydrogen-bonded water molecules are constantly moving in a loosely organized matrix, which makes it difficult for oxygen to diffuse to the area of lower concentration. Under normal conditions, oxygen's path through the matrix of water molecules can be circuitous and the progress slow. TSC increases the amount of oxygen that can get to tissues by increasing the rate of oxygen diffusion through the matrix of water molecules in blood plasma. TSC molecules are hydrophobic, meaning they repel water. Forces created by the unique shape of TSC have an organizing effect on water molecules, including those in blood plasma. TSC causes the water molecules to create more hydrogen bonds among themselves and form a more organized matrix structure. This more organized structure allows a shorter, straighter path for oxygen to move through the matrix of water molecules. TSC effectively increases the speed of oxygen movement through blood, allowing a more rapid rate of oxygen diffusion. This means oxygen-deprived tissue can get more of the oxygen that is essential for life.